So does this table look very similar to the one that we did last time? Yeah. Fractions, steps, operations with rational expressions. Okay? Well, guys, what is a rational expression? So you know that rational means fraction because look, ratio. What's a ratio? Fraction. Yeah. Okay. What's the difference between a rational expression and a rational equation? Okay, how about this? What's the difference between an expression and an equation? Yeah, absolutely. An equation implies that there's an equal sign. An equation implies that you're trying to solve for some value. An expression is just two parts put together or three parts put together or something. And the directions on expressions, really all you can do is simplify them. If it was an equation, you'd probably be asked to solve. You can't really solve an expression. You don't have enough information. Okay? So we're trying to, today, add and subtract rational expressions. All right? So let's talk real quick about basic addition of fractions or subtraction of fractions, and we'll compare that to our operations with rational functions and see how they compare. Can you make a prediction for me? How are they going to compare? The same, right? They're going to be the same. Okay? So let's look at problem number 1. If I have the fractions 2/3 plus 3/7 plus 2/7, how do I do that problem? What is required? Absolutely. Here's the rest of my question. What is required in order to add or subtract fractions? He answered very clearly. Excellent job. Have to have a common denominator. Okay? So, do I have a common denominator already? Yeah. So what do I do with that denominator? I keep it, right? Once I find a common denominator, I want to keep it. What do I do with the numerators? Add them. Hey, what is 3 plus 2? Yes, 5. Okay? Guys, what steps did we just take? What steps did we just take? Add the numerators. When what was true? When the denominators are the same. Oh, D-E-N-O-M. Now, do you think those are the exact words that it says on my answer key? No. Why did I write down these words? Because that's what you said. And they're just as fine as the words on my answer key. They're your words. I need to value your words because they're right. Okay? So, look here. Do I have a common denominator already? Do I have the same denominator for each fraction? Yes, so what do I do with that denominator? Keep it. X minus 4. We'll see how much you remember from yesterday here in just a second. What do I do with the numerators? Add them. What is 2 plus x? Thank you. It's 2 plus x. It's just 2 plus x. You can't add terms that are not like. Constants and variables are not like. Okay? Now, do I cross out the x's here? We talked about this quite a bit yesterday. Can I cross out the x's? No, because this x is part of this factor, and this x is part of this factor. I can't do that, can I? So what do I do now? Yeah, I go to the next problem, because we're done. All right? So let's go to the next problem. Now, sometimes we're going to want to do a little bit of extra work in the beginning so that we don't have a lot of extra work at the end. Remember how yesterday we talked about, as mathematicians, we want to do the least amount of math. Is that what I want to say? What did I say? Least amount of steps so we can get the most amount of math. Okay? We want to do the most amount of math with the least amount of steps. Okay? So, do I have a common denominator? I do, right? They're exactly the same. But when I write this down, I don't want to write exactly what's there. because I noticed something about this denominator. Did you notice that it happens to be the difference of squares? And that can be factored, can't it? I would get x plus 1 and x minus 1. Do you remember that? Again, we talked a little bit about that yesterday and just trying to help you remember. Okay? So did I change the value of the denominator or did I just factor it? Just factored it. So what do I do with the numerators? I just add them, right? I have a common denominator. I just add the numerators. What is 2x plus 5x? 7x. What is negative 3 plus negative 7? Oh, that's a positive 7, isn't it? Sorry, it's hard to tell on the screen. Negative 3 plus 7. 4. Okay? So guys, why did we factor our denominator? Why did we do that extra step of factoring our denominator? What would happen if in my numerator I actually got 7x plus 7? Couldn't I factor out a 7 from each term and get 7 times x plus 1? And then look what I have in the denominator. With x plus 1 in the numerator and an x plus 1 in the denominator, would those simplify to 1? Yeah. That's why I want us to factor my denominator as I go, just in case that happens later on. Plus, this is just, sometimes math teachers with a sense of humor like myself call these naked problems. There's no words that go along with this. There's no meaning to this problem. It's just numbers and letters. See what I'm saying? It's not a story problem about how Bob was walking his dog to the store and blah, 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 right? This is it's a naked problem. There's no value to these numbers. But what happens if there was really value to these numbers and the next thing I'm asking you to do was to find the vertical asymptotes? Don't I need this denominator factored in order to do that? Absolutely. Okay? So we might as well go ahead and do that as we go. Fair enough? All right, look at problem number 2. 8 over 11 minus 3 over 11. How is that different from problem number 1? It's just subtracting, right? That's the only difference. So what do I notice about my denominators? They're already the same. They're already the common denominator, so I keep the common denominator. And what do I do with my numerators? Subtract. What is 8 minus 3? 5. What steps did I take? Subtract numerators. When denominators are the same. Do I have a common denominator? Okay. Then I keep that denominator and I subtract the numerators. 2x minus x. X. 11 minus 9. Okay, guys, let me show you something. When people get this wrong, it's because they put 20. Why would somebody put 20 right there? No, I understand. I understand that it's plus 9. But I'm telling you, when people get it wrong, they're going to put a 20 right there. Why are they getting it wrong if they put plus 20? Yeah, they're forgetting to subtract. It's 11 minus 9. I know it's a positive 9. Thank you for fixing that for me, though, and just in case you thought I was reading it wrong. I appreciate that. But 11 minus 9 is 2. Okay, you have to remember to subtract the second term. And in fact, sometimes actually people go and put a parentheses around there so that they remember we're subtracting the whole thing, not just that first term. Okay? Questions about that? So now I cancel out the x's? No, why not? It's part of it, not a factor, right? All right, what about this one? Is it the difference of squares? It's a difference, 4 is a square is 3. Oh, 3 is not a square, is it? So that was good. That was good thinking. But I would realize pretty quickly 3 is not a square. So what do I do with this denominator? I just keep it the same. There's no way I can factor it, so I just keep it the same. Okay, good thinking though. What do I do with the numerators? Subtract. What are you going to get? Negative 8x, because x minus 9x is a negative 8x. And then? So plus 10. 3 minus negative 7. 3 minus negative 7. 10. Questions? Now, some of you notice that these are both divisible by 2. Should you factor out a 2 in the numerator? Well, is there a 2 waiting to be simplified in the denominator? No, so we don't have to do that. Okay? It's not something you have to do. Any questions so far? Number 1 or number 2? All right, what about number 3? 3 over 8 plus 1 over 4. Do you remember how yesterday I said, guys, I know where we're going, so we're going to do this a little bit different than what you're used to? Guess what we're going to do on number 3? Same thing. Okay? Think about with me for just a second. What are the factors of 8? 4 and 2, right? 4 times 2. So I know I don't have a common denominator because they're not the same. Okay? So when I go to try to figure out a common denominator, I'm thinking of this. Do these two denominators share any factors? This one has a 4 and this one has a 4. If they both have that same factor, that factor needs to be in the denominator of both numbers. Does that make sense? Now, does one of them have a factor that the other one doesn't? Yeah, this one has a 2, doesn't it? So that 2 has to be part of the denominator as well. Are there any other factors not accounted for? This one's got a 4 and a 2. This one's got a 4. Are those all listed here at least once? Yes. That's our common denominator then. Does anybody know what 4 times 2 is? Oh, 8. Good. Good, good. Okay. But think about this. What did this denominator used to be? 4 times 2. What is it now? 4 times 2. Is it missing anything? Then what do I do with the numerator? I leave it alone. Okay? Is this one missing anything? What did it used to be? 4. What is it now? 4 times 2. So what is it missing? Times 2. So if I multiply the denominator by times 2, what else do I have to do? Okay, most people today have been pretty good about being able to tell me what to do. Do you know why you do it? Do you know that if you multiply the bottom by 2, you have to multiply the top by 2? You know that. Do you know why? Because that's exactly right. I've got to keep the value the same. And what am I really multiplying by if I multiply by 2 divided by 2? What is 2 divided by 2? It's 1. Am I changing the value of a fraction if I multiply it by 1? Do I change the value of anything if I multiply it by 1? No. The 1 I'm choosing right now is 2 divided by 2 so that it will give me a common denominator. Okay? So what is 1 times 2? 2. Okay, good. Now when I go to write my answer, I can go ahead and write that as 8 in our case because we can multiply those two numbers together. What do I do with the numerator? Add them. 3 plus 2. 5. Done. So what kind of steps do you want to write down for that problem? And let me ask you this. Why, if this one has a 4 and this one has a 2 and this one has a 4, why do we only write 1 4 in our common denominator? Because what I was trying to find, that's exactly right. What I was trying to find was the least common denominator. Okay? I could have, my common denominator could have been 4 times 4 times 2, because that's taking everything that was in the denominator already, right? But if I'm trying to find the least common denominator, if they already share a factor of 4, I only want to write a 4 down one time, because that'll keep my numbers lower, keep me from doing more work. Okay? So look here. I'm going to go ahead and give myself a little template to fill out, like that. Okay? Is there a factor that both of these denominators share? An x, right? So both denominators need an x. Is there a factor that this one has that the other one doesn't? A 3. So that needs to be part of the common denominator. Is there a factor that this one has that the other one doesn't? Doesn't this one have a 1? Yeah? So are there any more factors, or did we take care of them all? Yeah, we took care of them all, right? So what did this one used to be? 3x. What is it now? 3x. What do I do with the numerator? Keep it. What did this one used to be? X. What is it now? What's it missing? A 3. So I multiply numerator and denominator by 3. So what do I get for my numerator over here? 3x plus 3. Remember, I have to distribute right there? Now what? Now that I have a common denominator, what do I do to the numerators? Add. My denominator's 3x. What do I get in my numerator? 3x plus 8. What do the crazy, crazy people want to do right here? Yeah, they want to cross out the 3x. That's not any of you guys. None of you guys wanted to do that, right? Because that's what crazy people do. Okay? We know we can't cross out the x of the numerator because it's part of the whole factor, right? Remember that? Okay. Any questions so far? All right, so what about here? What about this next example? What do I want to do first? I'm going to put this in parentheses in my steps, too. What do I want to do first? Yep, factor. Factor the denominators is all I really need to factor, right? So can I factor this denominator? Yeah, because it's a greatest common factor, right? So if I factor out a 2, what do I have left? X plus 2. Can I factor this denominator? No, it's already in the least that it can go, right? So I'm going to give myself a template to fill in. So, are there any factors that they have in common? Yeah, x plus 2. So I know that has to be part of my common denominator. Is there any factors that one has that the other one doesn't? Yeah, the first one has a 2, doesn't it? This one right here. So each of the denominators needs a 2. Is there something that this one has that the other one doesn't? No. So guess what this is? It's my common denominator. Okay? What did the first denominator used to be? 2 times x plus 2. What is it now? 2 times x plus 2, so stays the same. X plus 1. Plus? Yes. What did the second denominator used to be? X plus 2. What is it now? So what is it missing? A 2. If I multiply this denominator by 2, I multiply the numerator by 2. 18. Exactly right. What do I get in my numerator? Perfect. X minus 17. Anything I can simplify from numerator to denominator? No? So I just leave it. I'm done. Number 4. Fourth example. What are the factors of 7? 1 and 7. What are the factors of 5? 1 and 5. Man, do they share any factors really? Just 1. That doesn't help me, does it? So when I go to write my denominators, does this one have 1 that the other one doesn't? A 7. Does this one have 1 that the other one doesn't? A 5. So 7 times 5 is my denominator. Where did that come from? Didn't I just multiply the current denominators? Remember, I told you could do that up here, but we happen to have terms that were common, right? Or factors that were common. I didn't have any factors common down here, so this is a perfectly acceptable way to find the common denominator. Even the least common denominator. Okay? So what is the first term lacking? It was a 7. Now it's 7 times 5. So it's missing a times 5. What is the second term lacking? Times 7. Okay, so what is 5 times 3? 15. What is 2 times 7? 14. So what do I get? 29 over 35. Absolutely. Same steps as here. But I'm going to put this again. Sometimes we're going to have to factor, especially when we're working with rational expressions, we may need to factor. Not all the time, but we may need to. Okay? All right, so look here. I'm going to give myself a template. What are the factors of x? Well, just 1 and x. What are the factors of 3? 1 and 3. So what do you think my common denominator needs to be? Yeah, that's exactly right. We're going to write 3x. I know you could write x3 or x times 3, but, you know, traditional mathematicians, we write our numbers and then our letters, right? And our letters are usually in descending order of exponents, okay? So what's this one missing? A 3, so I need to multiply numerator and denominator by 3, and I get, good, 15. What's this one missing? X, so numerator and denominator by x, 2x squared. Absolutely. What do I get? 15 minus 2x squared? Yeah. Now, I just said that traditional mathematicians, we write our numbers, our letters first and then our numbers, and then we didn't write it that way. So am I just full of hot air? No, isn't it easier to write this way? Nobody says there has to be a specific form when we're doing addition and subtraction, right? Nobody said this has to be in like slope-intercept form or something. That's not even in our area right now. We're not even talking about that stuff. If I wrote it the other way, it would be negative 2x squared plus 15. And a lot of people don't like for their first term to be negative because sometimes they miss that negative. Okay? But for the record, either one of these are right. Okay? What about the last problem here on the front page? I got an x plus 3 in one denominator, and I've got a 2x minus 1 in another denominator. What do you think we ought to do to find a common denominator? Before, we've been talking about factors, right? What's the factor of this? One factor is x plus 3, and one factor is 1, right? We can't factor it any more than it already is. One factor of this is what? 1, and one factor is 2x minus 1. So what do you think my common denominator is going to be? Well, they both have a 1, so I could put it there. This one has a x plus 3, and this one has a 2x minus 1. Remember, just like this one, when you're in doubt, what should you do with the denominators? Just multiply them, right? If you're not quite sure, just multiply the denominators together. So this first fraction is missing a 2x minus 1, both in the numerator and the denominator. The second fraction is missing an x plus 3, both in the numerator and in the denominator. Now we've got to do just some basic arithmetic, right? 4 times 2x is 8x. 4 times negative 1 is negative 4. 7 times 3, 21. Well, it would help if I do my own math. 7 times x is 7x, and then 7 times 3 is 21. Sorry about that. Okay. Now I just have to combine my numerators, don't I? Because I have x plus 3 times 2x minus 1 in my denominator. What do I end up with in my numerator? Yep, 8x plus 7x is 15x. Negative 4 plus 21 plus 17. Excellent. So one of the things that I don't like about being a teacher is that they give me a really cool table to show you, really nice examples, and then the homework problems look like this. Where did that even show up, right? So I added some problems in here that look a little bit more difficult, look more like your homework problems, but aren't more difficult. Well, they kind of are just in the fact that they have more stuff, but that's what your homework looks like, right? So let's talk about number 5 up here. What should I do with my denominators first? Since they're not the same, what should I do? Factor. Can I factor my first denominator? Nope, it's already in its smallest form, right? Can I factor my second denominator? How? It is the difference of squares. We have x plus 2 and x minus 2. Nice. Okay. So I'm going to give myself a template to fill in. What is the first fraction? Well, let's see. Is there a factor that they share? An x plus 2, right? So I want an x plus 2 to be part of my common denominator. Is there a factor that the first one has that the second one doesn't? No. Is there a factor the second one has that the first one doesn't? X minus 2, so I need that as part of my common denominator. Have I taken care of all the factors in the denominator? Yeah, so that's my common denominator. X plus 2, x minus 2. So the first denominator used to be x plus 2, now it's this. What's it missing? An x minus 2. The second denominator used to look like this, now it looks like that. What's it missing? Nothing, right? So let's go and do our arithmetic at the top. 2x times x, 2x squared, 2x times negative 2, negative 4x. And what did we decide to do with this one? Yeah, just leave it alone because it already has the right denominator. Now all we have to do is simplify our numerators because I've got my common denominator as x plus 2, x minus 2. Okay? 2x squared, no other x squared terms. Negative 4x plus x, negative 3x, and then negative 11, absolutely. Now, is that something I could factor? I could think about it at least, right? AC gives me negative 22, and B gives me negative 3. Is there two numbers that multiply to be 22, negative 22, and adds to be negative 3? Not that I can think of, right? 2 and 11 really is all the factors of 22, 1 and 22, but neither one of those combinations give me negative 3. So, I'm done. Okay? Look at 6. What should I do first? Factor. Multiplies to be 12, adds to be 7. 4 and 3? X plus 4, x plus 3? Can I factor this denominator? How? Factor out of 2. What's left? 2 times x plus 4, right? I'm going to give myself a template. Is there a factor that they have in common? X plus 4. I definitely want that as part of my denominator. X plus 4. Is there a factor that the first one shares, or the first one has that the second one doesn't? X plus 3, so I definitely want that as part of my denominator. Is there a factor the second one has that the first one doesn't? Oh, a 2, so I definitely need that as part of my denominator as well. So this time my denominator actually has 3 different factors, doesn't it? Okay. So look at what the first fraction used to be and look at what it is now. Is it missing anything? Look at what it used to be. Look at what it is now. It's missing a 2, isn't it? Multiply numerator and denominator by 2. What do I get? 2x plus 12. Good. What about the second one? Is it missing anything? X plus 3. Numerator and denominator need an x plus 3. What does it become? 5x plus 15. Now, please, please, please remember that we are subtracting here. Okay? So when I go to subtract my fractions, I keep my denominator that I found, that's a common denominator, and what do I do with the numerators? Yeah, I subtract. What is 2x minus 5x? Negative 3x. And then? So 27? Why not? Oh, I'm subtracting. So 12 minus 15. Negative 3. And some of you are thinking, both terms have a negative 3, so if I factor out a negative 3, that's going to leave me an x plus 1. And that's good to know, but is there an x plus 1 to simplify in the denominator? No, so I can just leave it like that. Okay? Okay so far? Should we do number 7 or not? Yes? Okay. What do we do first? Factor. Multiplies to be 8, adds to be 6. X plus 4, x plus 2. Multiplies to be negative 6, adds to be negative 1. What kind? X minus, what'd you say? 3 and x plus 2? Because my middle term has to be a negative 1, right? So that's got to be a negative 3 and a positive 2. So what is going to be my common denominator? It's definitely going to have an x plus 2 because that's a factor they share. What else has to be in my denominator? Very good. An x plus 4 and an x minus 3. Those are the other factors that each denominator contain. They all have to be over here. Okay? X plus 2, x plus 4, x minus 3. So what's the first one lacking, if anything? X minus 3, x minus 3. So x squared plus 3x minus 3x. What's that? 0. And then minus 9. Remember we had x squared plus 3x minus 9. And that goes to 0. Okay? What's the second fraction missing, if anything? X plus 4. So it's here and then here. So 9x plus 36. X plus 2. X plus 4. X minus 3 is my denominator. What do I do with my numerator? Add. X squared is the only x squared term. Then I've got a 9x And then I've got negative 9 plus 36. Positive 27, absolutely. Does that factor? Multiplies to be 27, adds to be 9. I can't think of anything either. So we just leave it. Okay? Any questions about this? The only homework problem that I like to caution you on is number 2, and that's only so that you don't do more work than you have to. Fair enough? Look at the middle denominator. I think they're trying to trick you here. Because these are the same, right? Those are exactly the same, and this one seems like it's backwards, right? Well, what if I write it in the same order as the others? Negative 3x plus 1? What if I factored out a negative 1? What would I get? 3x minus 1. Isn't that the same as over here? So when you go to find your common denominator, what are these two missing? Just a negative 1. You don't have to multiply these all together to get your common denominator. Multiply this one by a negative 1 over negative 1, and multiply this one by negative 1 over negative 1. You see what I'm saying? It'll make it a lot easier when you go to start that. Okay? Any questions?